In this video, I'm going to show you how the activation and the anti-collision works when there are more than one card in the field. So as you can see here, I have connected the CR95HF demo board, and I'm just wanted to show you something interesting, before we get into this multiple cards. So I'm using the software, the development software, and click on this button. In the last video we saw how to read and write a single card. We are using SRIX4K, and it's very straightforward when there's only one card. As soon as the card is placed in the electromagnetic field, it is ready with a random chip ID. So what the PCD have to do now is send the initiate command, and the PCD has generated a random chip ID, and it is in the inventory state. The PCD can keep sending this initiate command. So every time the PCD sends initiate command, the card keeps generating the random number. Now if you have seen the documentation of SRIX4K, the documentation says we can have a fixed chip ID. So by doing that, the card will always generate the same fixed chip ID. There are some advantages and disadvantages of that, and probably I'll keep that for my next video. Now what you have just learned here is every time the card receives the initiate command, it generates a new chip ID. And I'm going to remember this chip ID now. So it's 8F. I'm just going to make a note of that. Just going to make a note of that chip ID. I'm going to show you there's something interesting you can do with this chip ID. So I'm going to select. So now we know that the card is in the selected state or active state. In that state I can read and write. So here I've just, if you see here, this is the content of the first block, that's the first OTP. I've made some changes here so that I want this to look like not just the default all F's, but FA, FB, FC, FT. So you should keep in mind SRIX4K is something, it has got a feature which is not available in most other tags. The interesting feature is the OTP is rewritable, which you don't see in I've not seen, in my experience, I've not seen in other cards where the OTP is rewritable. Okay, so once you finish reading and writing, let's go and read the system area. Remember I mentioned about having the fixed chip ID, so that is present somewhere in this block. So the documentation explains, so you can go and change here, right, but you have to be careful. If you just go, there is a button here to write single block FF. Just see what it does. Yeah, so I've never tried this writing, because you just cannot just go and write here without knowing the structure of the system area. So you have to keep in mind, writing to the system area, it's not something I would advise. Let's not do that. So I'm going to do something something different here. I'm going to select, now keep in mind this tag has a chip ID of 8F. So I'm going to make 8.1, or sorry, 8E, just one less than that. Okay, let's give select. Now the PCD is trying to select a chip with the chip ID 8E, and we know there is no card with chip ID 8E. So if you see the response here, it says frame wait time out or no tag. Obviously there is no tag, so there is no response. What has happened to our tag which is on the board now? Now this tag has gone to a state called the deselected state. So if you try to read now, you get an error message because there is no tag that matches the chip ID, and in other words there is no tag which is active or which is in the selected state. So obviously anytime you try to read, you'll always get an error. So you just have to get used to this, because sometimes 8.7 is a positive response, whereas in this case 8.7 is a negative response because there is no tag. So how do we go back to the tag which is already there sitting on the board? I know it is 8F, so let's select it again. So look at that. So this command has selected the tag, and if you try to read, you get back the data. So this is just a basics of how the multiple cards are read by the PCDs, and this is exactly what we are going to what I'm going to talk again pretty soon when we discuss about multiple tags. So we know now that this tag is in the active state. What happens if I send a initiate command? Let us click the initiate. So the tag will never respond for any of these commands, initiate command. Let's try to read. Still, we are able to get the data. However, we can force the tag to go back into the inventory state. So if I press that, now see, whenever you have to keep in mind, whenever you get this message, it doesn't mean it's an error. So you have to look into the documentation, okay, the one for SRIX4K. So this means there is no response from the tag, or the documentation says for the reset to inventory command, the tag doesn't reply with any data. So I'm going to start all over again. Now I've got two tags here. Just try to take it out. I'm going to place two tags. Not very sure how to place, but let's place something like this. So I got two tags. Go and choose that. So I'm going to clear. So we'll just try to do whatever we did for a single tag. Initiate. So somehow, as you can see, initiate is successful. There's only one tag there. However, in case of a multiple tags, you will get an error. So let's try again. Yeah, this is exactly what we wanted. Okay. Now, if the initiate command, what initiate command does is it will make every tag to generate a chip ID and transmit the chip ID. Now here, this is the scenario. Now here we got the PCD. PCD, and we got this tag 1 and tag 2. Both the tag has responded for the initiate command, and there is a collision. So whenever there is a collision, the CRC of the response, probably something, it's a CRC, or obviously the PCD gets a distorted data, or it gets a response which is not a valid. Now we know that every response has got a 2 bytes of CRC, and probably, I think, I'm not very sure, but for a developer like me, I don't want to get into what exactly happens at the bit level. It's not required for us. So I think the CRC will be wrong. So whenever there is error like this, so this indicates that there is a collision. So if you look into that example, okay, what I'm just having this on my other screen. What it says is you have to first, the PCD will initiate the pcall16 command. Now what this does, okay, this will make, let me check one second. So this pcall16 makes all the tags to generate a new, it says a slot number. So I think, let me, probably I missed something here. Probably I'll go back to my original slide. So sorry guys, probably I missed something here. Now let's go through this slide. I put some of my thoughts here. And okay, in case of more than one card, the states of the pick is something like this: from the ready to inventory. Inventory, it will go through the anti-collision loop, and one card gets selected. You can do all the read and write, and then gets deactivated. So when powered, we know that the pick enters the ready state and generates a random chip ID. PCD sends init to pick. All cards changes state to inventory and returns the chip ID. There is a collision. So whenever there is a collision, the PCD will throw an error. That's what we saw. So each chip ID, this exactly now I wanted to mention here. Each chip ID, see, we thought the chip ID is a byte number, a byte size number. So each chip ID has got the lower bit 0 to B3 has got the chip slot number. This, I would advise you to go back to the documentation. There's a very clear explanation there. Okay, so here this bit is called as a slot number, and because this is 4 bits, and this slot number can have value from 0 to F or 0 to 15. So this is how this is called, the algorithm is called as the time slot algorithm. I think the other algorithm is the probabilistic algorithm. So the documentation says SRIX4K is based on the time slot anti-collision algorithm. So it doesn't support the probabilistic something like that. So okay. So whenever there is anti-collision, what the PCD will start is, the PCD will start looking at any, basically, what the time slot here means, every pick is given a chance to respond. So from now on, every pick will get only one chance to respond. However, you have to be careful. You can still have a collision. So okay, let's make it simple here. So the PCD starts anti-collision algorithm using the commands pcall16, slot marker 1, slot marker 2, slot marker 15. pcall16 is also same as slot marker 0. Now what this does is, this slot marker command when this command is sent to the PIC, say for example, assume that we got a PIC here which has got a slot number 3. Now when the PCD sends slot marker 3 command, sorry, there's something wrong in my screen, 3 command, so all this PIC will match the parameter 3. If they are equal, this PIC will respond with this chip ID. So this is how the time slot algorithm works. And if it's still not clear, probably we'll try an example on SRIX4K, and if you read, as I said before, you have to read these documents multiple times. I did that, so it's a simple concept, but it is a bit tricky to understand. Okay, so once it is done, you can keep the PCD can do the read and write, then it will send the card for a completion command is sent. This will make the PIC to go into deactivated state. The PIC again selects the next slot. So basically the PCD selects the next PIC. So this thing repeats again and again until all the cards in the field are processed. So let's go and try this again. Alright, so let's try this again. Somehow we have to get this collision. Okay, let's place it one above the other. Place it like this. Now I'm going to try. So let's init. Oh yeah, this is something interesting. It says the framing error. I've never seen this error before. Not very sure whether let's try. Okay, now the first thing we have to do is initiate a pcall. So the pcall is also the slot 0, so there is no response from any one of these tags. Next I'm going to start sending the slot it's the slot marker command with 1. Already the software has got 4 bits here. So send the slot. Okay, we are sending the slot 1. What the PIC will do is if any PIC having a chip slot number with 1 will respond. When there's no response, that means none of these 2 tags has the slot number 1. We'll try the 2 just in a binary, so it's a good exercise going back in time. 2, no, there is no response again. Try 3. Yeah, slot number 3 gave me a response, and I'm sure one of the card has got a chip ID as 3E. I better make note of that. 3E, that's it. Let us hunt for the other one. I know I got 2 cards placed here. I'm going to check with the slot 4. Slot 4, no response. Slot 5, no response. Slot 6, no response. Slot 7, yep, I got one more response from slot 7. So, and the ID, the chip ID of the second card is 37. So this can be continued up to 15, and this is exactly what happens when you hit this anti-collision loop. It goes from 0 to 15. Probably after this, I never understood. First time when I saw the anti-collision button, I got so many messages here, never got it. So now I think this is very easy for me. So let's go with the try 8. Obviously we should not get anything here. Okay, nothing. Now the PCD knows the chip ID of 2 tags. That's it. Okay, that's it. Let's now this will you can repeat up to 15. Now I know that the chip IDs are 3E and 37. I'm going to select 3E. I'm going to select that chip. Sorry, it's not 3E, I suppose. Let us try the 37. Let's go back. Yeah, 37. I don't know why I didn't get 3E. Okay, so it's a 37. I've selected this 37, and let me read the first block. That's it. I'm able to read the first tag. Just a minute. Just go and see what is the tag. It's 43. Yeah. Okay. Oh, sorry. It's a 43, not 3. Sorry, I don't know why I got that number. I was wrong here. Okay. So it is 43. So it is 43. I took these 2 bytes. Sorry for that. Okay, so now we are able to read, and let's that I'm going to select the 43, select, and you got a positive response. I can read, and you get a different data here. So look at that, how easy is that? See, now it's easy. It was not before though. So this is how you can, this is what the PCD or our software, if you have to integrate this into a software, we'll end up remembering all the chip IDs you got. This is just a simple scenario. If you read the documentation, they got a few more interesting scenarios, but I'm not going to make any videos on that because sometimes it's very difficult to communicate those scenarios. So if you know this basics, I'm sure you'll understand the document. Now you can read and write, so you can keep swapping. I'm going to go to 37, select that. Remember, just before this video I showed you what happens when you select a different tag. The first tag will go into the deselected state, and just go and 4-3 select, read. How cool is that? So this is how the anti-collision and activation works for SRIX4K. and probably with this knowledge, I'm sure you'll understand any documentation on this type B anti-collision. Thank you.